Yeah, it's my great pleasure to introduce Ashleigh and Faith, who is the Director of Knowledge Graph Product and Semantic Search at EBSCO. And for anyone that's seen her honest reviews and YouTube channel, hopefully you're as impressed as I am at how rapidly she's covering the whole kind of knowledge graph, connected data space. It's incredible to watch. So I'm really excited about today's session. And yeah, just a quick thanks to the sponsors for making this event happen, Semi Technologies and Weaviate. And yeah, over to you, Ashleigh. Really excited. Thanks.
Wow, that was an introduction, James. Thank you. Yeah, I do the YouTube stuff in addition to a full-time job and doing research, so it's a lot. So let's get this party started. If you guys don't know me or you haven't seen my channel before, I am a pretty laid-back person. I hope to make this at least somewhat entertaining for all of you. All right, and educational. So can you see my screen? Speak up because I can't see anybody. I'm hoping you can. All right, so let me go and check to make sure.
Yes.
Yes, okay, cool, great, thank you. All right, so you might wonder, 2 hours and only 13 slides. That's okay because it's a lot of discussion. I am a strong believer in not just reading off of slides because you can all do that yourselves. You didn't show up to listen to someone read to you, but we're going to have active discussion throughout. So a brief agenda. So why does context actually matter for machine learning? Why taxonomies and knowledge graphs, and how those are useful specifically for context. Where this fits into the architecture and pipeline. I know that was one request from an audience member, so that's certainly something we will discuss. External data. This is one of the main focuses of this session because there's a great article that recently was published by MIT talking about how everyone loves the data modeling, but not the data work itself. It's because data is messy, as we all know, but we like the modeling part more than dealing with the data. And sometimes you can get around all the messy data in a way, obviously there's always going to be some, by just being a little bit more careful about which data sources we're using or which pieces of the data sources we're going to use. So we're going to go over that a little bit. And that's something that I'm going to encourage all of you to do with me. We will break into a discussion piece there. Then we'll see where we are at. If we need to take a small break, since I know this has been a long day for some of you, and it's later in the day for some of you as well. We can take a small break there if we need to. Then we're going to talk about your internal data. And what if it's really crappy? What do you do with it? Or what if you don't have a taxonomist? Or if you don't even really have a connection to your user group or your end users to understand what do they actually need for you? And one thing that I want to preface this by is this presentation is going to go over general understanding of linked data, specifically for features and feature extraction. And I usually work in the search and search engine optimization kind of that side of the house. So if you're expecting something that is focused on maybe like other kind of graph use cases, that's probably not something I'm going to cover here. But these things you can also use for auto tagging your content. How do you extract meaning from full text? You know, those types of use cases are definitely in the category of what we're going to talk about. And then how do you pitch a project to your manager and your C-suite? That is going to be how we conclude this. So hopefully you can take this information and go back to whoever you have to talk to and try to do some of this at your own institution or company or wherever you are. All right. So why does context matter? So these are some areas that I wanted to focus on. So we've got context, but only in a very individualized kind of perspective. So if you're using something like Comprehend, which is what I use a lot on AWS, yeah, you can get some of those key phrases And the entities, if you're not using a model you've trained yourself, which you probably should be, but just out of the box, it doesn't do a great job at entity recognition. Again, because it's using the AWS pre-trained materials. And then when you get into key phrases, you can get some of that context by looking at nearest neighbor and some of the other tricks and tips that we all know about. But here's an example of weight. If you're looking at the word weight, and in this context, it's about weighing something. So weighing something in computer science is something where you are emphasizing something else. Whereas if you are weighing something in the biosciences, it's probably how much something has for mass. And it's strange because they are very similar contexts. So even if you're looking at nearest neighbor, you can still get it wrong. So that's one reason context is important, is because if you just get this list of extracted terminology, it doesn't have a lot of context. And even if you use some other means with machine learning, you can sometimes often miss that context. Another one is in this top corner where we have the Shin Buddhist sect, and then it's also showing up with Shin as in the Hebrew letter Shin. So that's a missing context, right? So the context here is religious context versus language context. Having additional metadata, you can see the metadata here on the screen is actually very, very slim. It's one little tiny sentence. And having better categories. So this center node, this is graph data over here, has a discipline and has a category, and that's language and linguistics. But this one over here does not. It's just a related node. So what that means is, as you all probably know with machine learning, it doesn't have a lot of context to go off of, so it's just looking at a string and it's matching it. Another one that I want to focus on is what happens with over-indexing. So we're going to talk about the other side of the coin in this presentation, where if you understand why some of these vocabularies and data sources are created in the way that they are, it will help you understand how to correct and watch for those issues when you are selecting and integrating those data sources. So this one here is from the Microsoft Academic Graph, and this is something that I do believe is freely available. You can just grab it with their API. But hold on a second, because if you look over here, it's a little hard to see, but if you see down here, there's a lot of terminology, subject tags, that were associated with this article. And you can see this article is nomenclature for factors of the HLA system. HLA is a health system. So if you look over here at the top topics and this graph at the top, this is showing what is the top cited paper in history for last year. History. This is talking about a health system and nomenclature, nothing about history. But because whoever was putting this model together did not realize that the hierarchy of some of these terms, these subject tags, rolled up to a history term, they didn't realize what was going to happen. So I reported this on my channel 4 or 5 months ago, and Microsoft still hasn't fixed their model. It's one of the top subjects that you can go and check out, like an overview of research. And yet over here, the very top article is this health one. So that's a little strange. How do you avoid some of these things, and how can you find out if it's going to happen? All right, so before we get into that, what is the difference between a taxonomy and a knowledge graph if you are not in this space? So taxonomies are often created from information professionals or librarians or people that are working traditionally in the document and asset space. These are usually tagging those documents and assets. And while you will see a wild west of different tagging and indexing techniques, the most popular that you will see is just keyword extraction. How's that any different than the machine learning that we all do? Answer is it's not. And so when you are dealing with human indexers, or vocabularies or data sources from human indexers, which is often the case, actually. A lot of them were created years ago, and they're just keeping them updated, perhaps, with machine learning extraction, but they were originally created with humans. You know, focusing on the aboutness is actually what gives strength to taxonomies. And here's what that modeling looks like. So you'll have the creative work, which is the asset, and is about, and then the subject. And subjects in vocabularies can mean named entities, it can be topicals, it can be a geographic, but they are all in the aboutness or the keyword or subject tag. So there's a lot of resources you can use that give some of this data to you. BioPortal is one that I will talk about a lot in this presentation because it's open source and it also has a lot of this kind of information in it. There's something else called Connected Papers. If you've never heard of it, you might want to Google it right now because it's pretty cool to check out. And if you are a published author, you might want to go look at yourself on there and see what they're connecting you to. This is something else that I don't think is necessarily part of the personal graph space, but which I do believe all of us, especially that, you know, maybe have an ORCID ID or something, we should be checking a lot of these other sources, at least the big ones, that connect all of our works together, because if that gets tracked in a funny way, it can hurt your tenure. It can hurt your standing in the community, because maybe somebody publishes poor research and it's somehow connected to you, that they cited you as something that they adopted in their own research. So checking what is connected to you is also a good idea in some of these resources. Now, jumping over to knowledge graph. Speaking to all of you, this might be controversial, so that's okay. But in a general sense, we all know knowledge graph is connecting one thing to another thing in a highly explicit kind of relationship, whichever kind of graph you're working on. The way that I define a knowledge graph is the word knowledge is key here. You can do a lot of things with graph. In fact, Neo4j only recently started saying things about knowledge graphs. They've always been a graph database. But when I think of knowledge, it's retaining that implicit or that tacit information that you have. So it doesn't necessarily have to be the information that you would find in research. So if I had a research article and it was about over-the-air updates in electric vehicles, nothing in the title, nothing in the abstract, and maybe nothing in the full text actually talks about cybersecurity. But if I was a taxonomist at IEEE, this is a true story, by the way, I would know that over-the-air updates are highly susceptible to cyber attacks because your computer is this thing that you drive around on now with 4 wheels. And so because I knew that from being a subject matter expert, I could tag that to the article. That's knowledge that you can't find in the taxonomy, but you can build it into a knowledge graph. The other thing with knowledge graphs is that these are usually subject connected to another subject or a topic connected to another topic. I have had a lot of people point out that knowledge graphs just mean these bubbles and lines because they see that all the time. And of course, this is not somebody that's working in the knowledge graph space. But, you know, if you do hear people get a little confused about knowledge graphs, I'd really encourage you to try to explain it to them. And if you need help doing that, I have resources that talk about that. I know I'm pretty good friends with the head of knowledge graph at NASA. I know he was talking about doing something like that. There's a lot of us out there that want to create the magnum opus of what is a knowledge graph. So if anybody is interested in helping with that, that would be a good project for all of us to take away from in this. So when you're dealing with knowledge graphs, I have always been taught, and you know, I've I've studied with some of the most talented people I know in the knowledge graph space. And you've met some of them that are at this conference, others from my PhD program, fabulous people that work in this space. They always taught me you cannot have a good knowledge graph without a good taxonomy. And it's funny because a lot of knowledge graphs don't ever use taxonomies. And the reason for this, not the reason they don't use it, but the reason that a good knowledge graph always uses a good taxonomy is because of that context. Not mentioning specific names, but a few of the major streaming services, two very big ones that you all know and probably use, I was helping them with this exact problem because they have armies of machine learning experts, armies of people working on knowledge graph. And yet they didn't know what a taxonomy was, where to find taxonomies, and how to understand how to use them within their knowledge graph. And the main reason they needed it was for context. They didn't have any idea of how to add back in some of this context. And there are certainly machine learning ways to do that. But a taxonomy is a really easy way to do it if you can get a hold of it. All right, so why not just use those linked open data sources, those vocabularies that are out there as is? So you all might be familiar, perhaps, with the linked open data cloud. If you are not, please go check it out. It's actually a really cool exercise to see how it's grown over the years. Because when I first started using the linked open data graph, it was a lot smaller than it is now. The thing is, though, a lot of those data sources overlap, and not all of them are made with machine learning in mind. Not all of them are also vocabulary. Some of them are like Crossref or ORCID, or things that are talking about research in the industry. Now, I work at EBSCO, so that's my main thing that I work on is research articles. If you don't know this, EBSCO is the #1 search engine for published research. So I have to deal with taxonomies from over 50,000 publishers a day. And these vocabularies are constantly changing. Some of them are really icky because not all publishers are created equal or have the same amount of staff. And so I've encountered a lot of this, and most of those are not in the linked open data cloud. Most of those are just taxonomies that are being used. But as somebody that also digs into machine learning, having access to every article of Times Magazine and the New York Times and Forbes and every other academic research that's ever been published is fun. It's not all in machine readable format, so keep that in mind because some of the older content is not really that digital. It's just more of like a photocopy kind of thing. But the data that is available in XML or JSON documents, it's really fun to play with. But when you're digging into data that you don't own, which is the name of the game for me at work, and for any of you that are dealing with the linked open data cloud, you have to kind of figure out what's in there and what works. So these are mostly dealing with specific use cases. Now, in the LOD cloud, you can see that they do have color coding for generally which domain, but still some of them are very broad. So here's a good example. So the Library of Congress subject headings, those are the topical kind, well, it's not only topical, but those are the main aboutness features that you find across most scholarly information in the United States, Canada, and I believe the UK as well. Also maybe Australia. I don't know that one for sure though. And so the thing with that is because they are being used for a general purpose, they are not very deep. So I have worked the most with the STEM community. I actually used to work at IEEE, NATO, a lot of STEM military kind of applications. So what I did is I took a leading vocabulary for engineering. It's called InSpec. And I try to map how much of that really deep knowledge was available in the more general Library of Congress? And the answer is only about 50%. So it's not terrible. It's also not that good. So when you're going through these, you really have to understand, for your use case, do you need really broad, really narrow, or do you kind of need a mix of the two? Because some of them will be so specific. One is the Transportation Research Board. That is another government organization in the US, and they have their own vocabulary as well. It's just very specific to their use case, so it's not that useful for anybody else. Then this is the other thing. If you haven't seen the new publication that just came out recently, I can send the article to all of you. But there is a lot of errors, misalignments, and offensive content in these resources. So they found up to 3.5% of them contained really, really bad errors. And one very popular training set, it was used, I believe, for image tagging, had a very high percentage of 54%. So if you use that in your model, or if you used any of these examples in your model, how well would it do? Not very good. So really understanding what you're putting into your models is incredibly important. The next is there's not a lot of deduping. Things just kind of reside out there in cyberspace. And we will go through, and I'm going to train you on how to assess these data sources so you don't have these mistakes as often as you might today. Linked data also has different levels of trust. So there's quite a few out there that just because they're not maintained or because they are using data on the fly that is coming from, let's say, Twitter, and they're not scrubbing it at all, there can be some really offensive things in there. So you just have to be aware of that. And then not all of these are calibrated for machine learning. So what is a 1xx and a 9xx? Most of you will probably look at me with a blank stare here. So a 1xx is essentially looking at, there is a Library of Congress entity in most countries. France has one, Germany has one, G&D, anyone from Germany, good job, G&D, they're great. Mexico has one. I mean, there's tons. The Japanese is called the Diet Library. They all have these giant data sources, and it's great because they're almost all linked data sources, so you can train your models on them really well. They must be authoritative, right? Because they're, one, from the government, and two, they're being maintained for all of the different publications and library resources from that region. Okay. They still all suffer from these things, though. Don't be fooled. They are good to use in models, but you have to be very careful with what you're looking at. So, as an example, a 1xx, there's tags on these things. They're not unique identifiers. That's not what this is. It's more of a code, more like an ICD code. And so this code for a 100 or 150, that indicates it is a controlled term. It should be used as a main tag on content or a main feature in your machine learning. But don't use anything with a 900 in front of it, because those are controlled, uncontrolled terms. And you might be like, what does that mean? So oftentimes, the vocabularies cannot get updated fast enough for machine learning models or for even human indexers to use them. So what happens is a 900, a suggested term, if you will, is added to the vocabularies. Now, for people that are not familiar with these tags, you might not realize that you need to exclude those from your models. So if you see them, please exclude them from your models. They are not good to use. In fact, you would be better off just doing more of like a bag of word entity extraction on your own than using the 9xx's. What's the difference between a controlled term and a keyword? So this one is a little bit controversial because in the publishing space, in the academic research space, when you're training models, you don't want to use keywords. And here's why. So if any of you have published things, don't you kind of want to like add a tag, a keyword, an author word to your research that really highlights what your article should really be tagged with? But is it really about that? Not always. And so just be aware that keywords are more aspirational than fact. This is something that I have learned through all of my machine learning models at EBSCO. You have to be very careful with those keywords because they're not always accurate to what the article is about. And the controlled has a whole nother slew of problems that we will talk about. And then what does linked data and what is a map data? So linked data, as you might know, is like a wiki article, right? Like you have a wiki ID, you have your wiki ID, and that's your link to James Cameron and all the other information about James Cameron, for instance. But mapping can use linked data, but it can also just grab and scrape the data and put it into a model. And unfortunately, that happens a lot when some data source, it's a linked data source, but it's not got a REST API or even any API. It just has some sort of download or some other kind of documentation that you have to grab it from. So those are not ideal, but if there's nothing to link to, that's all you have. So that's usually the difference between linked and mapped. You can find them kind of intermixing a little bit, but usually you'll find more linked in data sources that are automatically generated, and mapped is usually something that has machine learning assistance, but then it has human in the loop after. So I was explaining why you don't want to use these as is. These examples down here are real examples. So in the Library of Congress subject headings and tags on documentation, I should say, you will see these things with dashes. So if you're not familiar with this space, there is something, the difference between pre-coordinated and post-coordinated. So when you are dealing with pre-tagged documents for your training models, you might find these. What you need to do is blast them apart or squish them together. So here's the difference. When a human indexer is indexing content, they can mix and match certain topics from taxonomies. And that is pre-coordination. They are pre-putting them together in the tag before it gets shipped off onto product or into your models. But you get these weird things like dog dash dash food dash dash recipes. It's gross. Machines don't do well with this. And if you're not aware that this is happening, you might not be able to prevent this getting shoved into your models, and that's not good. What I actually suggest is if you can take the dashes out and it reads as a string, and you can do that with fuzzy matching, then leave it. Like cybersecurity is a good example. Or you use them as individual entities. So you have dog as an entity, food as an entity, and recipes as an entity. That's not the better solution, but if that is all you have, that's better than using these pre-coordination topics. All right, so common issues, and then we're gonna do something fun, hopefully, with each other here. All right, so the common issues to watch out for, and I have some examples here. So outdated terminology. So that's this area down here at the bottom. So I am not going to mention which tools I was using because I don't want to highlight bad things. But in an academic search on Donald Trump, or no, I'm sorry. I searched on golden showers to see like how bad is bad. And Donald Trump was the very first thing that showed up. And apparently there are articles about that, and I didn't want to read them. But yeah, that's not great. I don't think I want to teach my machine about that if I don't have to. I mean, it does certainly exist out there, but it really depends on your use case. In my space, I am dealing with education and peer-reviewed and more scholarly academic things. So showing things like this isn't that valuable. The other thing you have to be careful of is that context that you might be getting from those linked data sources that you don't realize. So this one down here is bullshit. It is a card game if you're not aware of that, but it's also a swear word. It's a naughty word that people can use. So you can see the contexts are all mixed together here. The other thing is you can have something that's very offensive. So this model was also trained on Twitter data. So apparently lots of people were calling a certain church, I did cut it off so you couldn't read which one was, a certain church group is bullshit. I'm pretty sure that's something else we don't want to train our models on. So these are real examples for things that are already out there in the universe. So try to avoid that. And here's some ways to avoid that. You have to be able to look at the data that you are ingesting and make some of these calls. Another one is the circular logic. You're probably all familiar with that, where electric vehicle it's showing up in knowledge graphs. Have this a lot by accident. If somebody isn't looking at how many hops you have between different topics. And you see this all the time in taxonomies, because sometimes the taxonomy is so large and it's a poly hierarchy, which means the same child can be under different parents, which also is difficult with machine learning if you aren't aware of it ahead of time. This can lead to some circular logic, and when you are dealing with your models, it makes the machine very, very confused. It drops your precision way down, so be very careful. Another thing over here, this is the Transportation Research Board, scope notes and definitions. So these pieces of metadata, scope notes and definitions get confused all the time. If you go to the Library of Congress subject headings, they mix and match these as well. There's a lot of resources that mix and match a scope note, which is supposed to be, and if any of you are familiar with SCOS, this is there. So if you're dealing with SCOS, don't make this mistake. Scope note is how the machine learning should use this in enhancing your content, meaning, auto tagged or what semantic enrichment, whatever you're doing with it, or how a human indexer should use this term when they are tagging something. And you might think, well, how's that any different than a definition? Well, sometimes, especially like in the medical space, or in the legal space, or in the finance space, there are certain regulations that have to be associated with things. It's an asset, a person, what have you. So you have to sometimes tag where the person resides, whether in the United States or somewhere else. So that's a rule. That's not what that article is about. Now, I am of the opinion that information shouldn't even exist in the aboutness tag. That should be a different field. But if you are putting it in that subject place, make sure that you know the difference between a scope note, which is the rule, and the definition, which is what is this thing? How is this thing defined? And you can see here that they not only have confused this, but they have used the same exact definition. So that's not helpful either. There's a lot of outdated things that we also have to watch for. And this is not, I know I keep picking on the Library of Congress subject headings. I only am saying that one specifically because it's free, it's open, you can go and look at it right now. But this happens in every single vocabulary I deal with, every single knowledge graph that I deal with. And that is, outdated or historical terminology. And again, for your use case, you might have to use outdated terminology in certain situations. So you have to make sure in your model, you are tagging that so that your machine learning is not seeing this historical context, which is probably going to have a lot larger of a training set potentially, or it's going to contaminate your training set. And you have to be very careful that that doesn't happen. And then my very favorite is this one up here, which is over tagging. This happens all the time. This is very important for this session. If you take nothing else away from this session is first, check your linked data better and your internal data better. in an overall sense. But the second thing is do not over-index. And if your data sources and your training sets are over-indexed, you need to address that before you do any modeling on it, because this happens all the time. So we've got plastics here, and then we've got recycled plastic, and then we've got environmental dash dash, there's those dash dashes, plastic. You see plastics all over the place. Why? It's over-indexing. And then this happens a lot in pre-tagged content. You see this? First of all, it's in reverse order, Wells, comma, Sam. But do you see who the author of this article is? Yeah, it's the author. That's not what this article is about. So this happens all the time. So if you are using any content for your machine learning models that has, it's pre-tagged by human indexers somewhere, I guarantee this is going to show up somewhere. So be aware of it and be very careful of it. The complicated thing is some of these named entities can also be in a taxonomy. Here's the example. Mark Twain is an author, but there's also articles talking about Mark Twain, the author. So there is a difference between the aboutness, the subject, tag, and the actual author. So it is sometimes tricky, but one easy method is to just take them out of the tags, because most of the time, structured documents, the like Mark Twain would be in the title or the abstract to say what this article is about. So you most likely will be able to grab that. Or you can have a separate model that's just looking at named entities, which is what I do. All right, so we've gone over outdated. I know this came up yesterday. Fuzzy, BTs, and NTs, broader terms and narrow terms. So when human indexers and human taxonomists, by the way, when I say indexers and taxonomists, some organizations have them as separate people, and a lot of organizations, they are the same person. So just be aware of that when I say that word or those words. Most often, a taxonomist is looking at branches of a taxonomy in a microcosm. They're not necessarily looking across the rest of the vocabulary. When they are adding synonyms and related topics, so use fors and see alsos, they will most likely, like if you're using a tool, which a lot of people do, like Pool Party, they have a taxonomy and an ontology manager. I know Semaphore has one. There's quite a few of them out there on the market. They usually have like a type ahead where if you start to type in something that already exists, it'll show up. So that usually gets caught. What doesn't always get caught, and I have frankly been told by managers in my past, don't worry about it. It's not a big deal. That was before I showed them what happened when you feed that into a machine learning model. Doesn't do well, because then a machine learning model doesn't understand the difference between one branch and another branch. Not really, because it's looking at each thing as an individual node that is a child. It doesn't realize that that child is a different type of leaf. So that's something just to keep in mind when you're going through this is if you can look at the metadata, meaning is there a use for, see also kind of information, you can usually figure out if it's a part of or a type of, right? I think that also came up yesterday. So sometimes the child will be parts of the whole, right? So that's the part of relationship. That also, by the way, is there's a inverse of that in Dublin Core, if you're interested in it. It's not in SCOS, it is in Dublin Core though. So that's the is part of, has part, I believe, relationship. Don't quote me on that exactly, but that's essentially what it is. But you will be able to understand based on the characteristics of each of those child nodes, if it's parts of a car or is it different types of a car. So you might not be able to find that from the label, but you will be able to find it from the metadata if you have it. I'm going to go over if you don't have it, so don't worry. Okay, bad form. I showed you the reverse order of things. Sometimes you'll see vocabularies that are really flat, and so they don't have a hierarchy. So in a good hierarchy, you would have astrological bodies and then Jupiter. So you would know that it means Jupiter, the planet, versus Jupiter, the Greek god, right? But some vocabularies don't do that. Some of them will say Jupiter, and then in parens, it'll say the planet. That does terrible in machine learning. So a good strategy is, again, all of these things are pre-processes. If you're getting a vocabulary in, if you're getting an external data source or a linked data source in, check these things before you use it. That's the main takeaway here. Talked about over-indexing, circular logic, categories versus specific tags. So I had this happen in my knowledge graph project, and I was so mad. So I had one vocabulary that came in, and I didn't learn my lesson, and I didn't check it ahead of time. I said, oh, you know, this is a trusted partner. I'm sure it's fine. It was not. So thankfully, I didn't push it out to product before I caught it. So this one vocabulary had more of a category kind of bucketing system rather than a true taxonomy. So here's the difference. They had sports, or was it sports? Yeah, they had sports, and then all the children under that were all the sports, every single one of them. So there was no deeper hierarchy. It was recreational activities. That's what it was. Recreational sports were underneath it as children. But here's the thing. I thought they were just children. They weren't. They added them as a use for, a synonym. You can imagine how that turned out terribly. So just make sure when you're going through, do just a spot check on what synonymous kind of relations are in the data source, because it completely wrecked my knowledge graph for a while. It had the knowledge graph I use, I embedded into the search engine to do search expansion. And what happened was anytime somebody typed in any sport, this very generic search result came back, search result list came back, because it was linking all the different sports to one category, which is recreational sports. That didn't work very well. So that publisher doesn't have a lot of content compared to others. And so what happened was, that's fine for them. That worked for their use case. It did not work for my use case. So be careful about that. Unknown and unfriendly schema. That one is just, I know a lot of tags for modeling reside in XML. If you are dealing with published content, hopefully they're using JATS. JATS is fantastic, and it's so easy to do zoning, and it's machine learning paradise if you can get JATS. If you can't get JATS, or at least a JSON document, that also would work well. But if you're using something like OCR, ick, those are hard. And then overly unique terminology. This is where you would think machine learning does really well, but sometimes something can be so unique. Anytime your machine sees that in the search context, or even in the document space, it'll tag it. So it'll overly tag that very specific topic, because it has associated so many different characteristics to that topic. So for instance, I was doing recently a machine learning project where we were trying to identify news articles versus white papers, because sometimes they come in from publishers as the same thing, or they don't even tell us what it is. And so what we were seeing is we learned, our model had learned that sermons, as in like religious sermons, was connected to just standing at a podium and speaking, essentially, if you looked at the vector that came out from that. And so 90% of our content came in as being a sermon. That wasn't right either. So again, learn from my mistakes. All right, so with all of this, how do you fix it? How can you make sure this doesn't happen? All right, so after this, we're gonna take a break. Don't worry, because I know we've been at it for about an hour now. All right, so what I would like you to do, and after I go through this list, we can break out into discussion again. So if you have your favorite data source, go through, get it up right now as I talk. And if you don't have one in mind, go to VIAF or BioPortal and just find one. And we're gonna do this in practice. How do you assess all the issues that you might find in these data sources? Now, all the things that I just mentioned, those are pre-processing things that you need to do for any of them. But how do you select a good linked data source? And when I say good, I also mean responsible, because remember, there's a lot of things, if you don't check, could introduce a lot of biases, a lot of hurtful things into your models that you don't want. All right, so the first thing is provenance. So for those of you that are not familiar with what that means, and if you are dealing with data on your own and you're making data on your own, please include this. Who created it? When was it created? The whole data set. When was it created? How often is it updated? When was the last version? Version control, please give me some version control. So typically, here's my advice to you. If you are looking at data sources that are in the sciences and STEM space, do not use anything that has not been updated in more than 2 years. So if something was only updated 3 years, don't use it, or use it very sparingly, or use it with caution, because that space, the technology, the terminology, it changes so fast that you don't want to use something that hasn't been updated, in that amount of time. If you're dealing with things that are legal, you can go back potentially like 15, 20 years, because legal, there's precedence, right? And that's something that doesn't change a whole lot. And in the more humanities space, it's, again, a 10 to 15 year time span. But if you're trying to use data sources that haven't been updated, or they don't get updated often, even if you're taking just branches and pieces of that data source, really look, if it exists, when was the last time it was updated? When was the last time somebody reviewed it? And if it doesn't exist, that's a risk. And if you are an agile user like I am, are you going to accept that risk? Or are you going to mitigate that risk? What are you going to do? UIDs and APIs. So UIDs, 100%. I really like, you got to have a really good case for me to use data that doesn't have at least some kind of UID. APIs, RESTful or not, I can get around that. It's a little bit more difficult though. So you can actually take some of these steps and understand how difficult it is to get this data in, and how is it going to be to maintain it. So when you're building out a model, these are things to also consider. The pre versus post coordination, that's something to also think about. Do they have definitions and not scope notes? I honestly don't think, because it's confused so often, don't use scope notes. And are there citation and links to definitions? That would be very helpful. How are sensitive topics and historical data handled? Honestly, this is something that's so new, unfortunately, in the industry, that I don't know if this actually exists very often. I do know of a handful of vocabularies that are starting to do something like this. My knowledge graph, for instance, does this. But this is something that if it doesn't exist in the data source that you're trying to use, you need to do it. And we can talk about that and how you would go about doing that. How many ingoing, outgoing links? That's just talking about how often is it refreshed? Are there a lot of people investing in it? That sort of thing. Same thing with a code base. Like, you're not going to use a code base that like 5 people use. Kotlin. Did I say that? No, I think that's actually used more often now, but that was a joke. Who maintains it? What's the data governance? What is the root source of the data source? A good example is, it has been corrected, by the way, but I was using Wikidata for some machine learning models, and we had trained it on the synonyms. And one of the synonyms for cancer, as in tumor kind of cancers, there was apparently a brother group out on social media that was so mean and so nasty and toxic to everybody that everyone described them as toxic and a cancer. So in Wikidata, I wish I had taken a picture because I use this example all the time and it doesn't exist anymore, which is good. It means it's auto-corrected, right? So anytime like these two guys showed up, they were considered a cancer and vice versa because it was considered a synonym. Also think about, is it a general or a specific domain, and what kind of schema and framework is it on? Okay, let's jump back into discussion. And if you want to take a screenshot here, it might be a good idea if you're still working on assessing one of your favorite data sets. So I'll give you 5 seconds. Okay, hopefully you took that. All right, so are we back to discussions? So I'm trying to look at the chat here. So somebody asked, can you make the slides available? Yes, absolutely. I will send that to the folks at Connected Data London, and they will have the list of everyone that attended today. Let's see, what else do we have? Is there a case for a standard structured scope note to support ML? What do you think about SCOSXL? Oh yeah, no, I love SCOSXL. SCOSXL is really helpful. SNOMED, yeah, one thing that irks me about SNOMED is while it does have a tiny amount of definition, it has them only where they are not really needed. There's a definition for sand. Yeah, I agree with you. You know, if you're using SNOMED, NCBI or NCTI, I think is the taxonomy piece. They have really good definitions. If you haven't looked at that, they don't have an API, unfortunately, but they do have a bulk download that you can try that will have good definitions. All right, so, all right, so can everyone talk? Are we wanting to talk? I try to be interactive, guys. I hope you realize this by this point. See if there's any. Manage the UK version of NHS. Yeah, okay, cool. Yeah, I mean, I love medical data. It's the cleanest I've seen. I mean, that makes sense. They were the first kind of in the biz, but I just wish everyone else would get on the same page with that. I would say some of the messiest data that I see is in chemistry, which is kind of surprising to me because you would think chemical compounds, they're well known, there's a very clear structure, but the data itself is kind of messy. All right, so does anybody want to jump on and even suggest which linked data source they are looking at, if any? Let's see, what else do we have? Oh, okay, I have another question here. I didn't see it. Have a particular concern about the diversity and inclusion of the data. So why storing the source, origin, metadata, et cetera, in the KGs is so important? Yes. And in the slides, I'll also put some resources that I've mentioned. There are some really great articles out there talking about what kind of provenance needs to be there. Something that bothers me a lot is you get not just in English, but a lot of models that just automatically do translation of the features that are extracted because there's not enough content in a certain language. And that bothers me a little bit because, as we all know, direct translations are not always accurate. And so, wow, it is really windy here if you can hear that. It's like a huge snowstorm here in New England. It bothers me a little bit because I also hear often when I talk to engineers, hey, we need to make sure that the international natural language at the very least, we have to go find other additional data sources for that, is captured. And their answer is, well, we don't really sell overseas. You mean we only have people that speak English natively in America and Canada? Do you see the disbelief here? No, that's not true. This is something that I'm constantly fighting about, discussing with people to make sure that they understand. Even if you look, again, with my customers, they're all from the academic space. If you look across all the different universities out there, you can actually look up, in a general sense, their student population and where they come from. And there's so many students that are coming from other places and they don't speak English as their main language. So that's something that we can do in our models to help. Okay, let's see. Do I have more here? I'm interested in DBpedia. Okay. Yeah, DBpedia, it does suffer from a lot of these things. It is something that, you know, it's good for what it is. I mean, don't get me wrong. I'm not saying don't use any of these data sources, because I certainly use all of them. I think that, especially with the responsible AI component, we just have to be more aware of what we are using it for. And do you need some pre-processing or post-processing to address some of those issues? Because, again, to my knowledge at least, DBpedia gets updated way slower than Wikidata, for instance, and some of the other data sources that are out there like this. But you can still find some of those outdated terminologies, because what a lot of people don't realize is these main data sources, like Library of Congress subject headings, for instance, DBpedia. So DBpedia is predicated off of more of a folksonomy, like regular people just adding information or writing information. But like the Library of Congress, the German National Library, they all contract out to get their vocabularies updated and their taxonomies updated. So sometimes things get updated, sometimes they don't. Some things are entered in that are offensive because they're not really checking the work of those contractors. Let's see what else we have. In your example of Jupyter and the different contextual meanings, how do you differentiate them for ML purposes? Is it all in the metadata of the term? So no, that's where the taxonomy comes in. So as I mentioned in the example, if you have astrological bodies as a broader term and Jupyter is under it, you can traverse the path back to the broader, however many broaders you want to go, and that gets you the context. That's why, yes, you can get context with machine learning. We all do it every day. But if you can grab a taxonomy, you don't have to do any processing for some of that context. It's just there to use, which is really helpful. And then, yeah, with the metadata, you're lucky. You're really lucky if you get metadata. And if you can go and grab metadata, you're even luckier. All right, so we are at 11 past. So I don't know if you got a break with Pacos, but I want to make sure that all of you have bio breaks and go get a drink, and you know, have some energy for the next portion where we will dig in a little bit more. Oh, I see some typing going on. So I'm going to start it back up at 3:16. I will stick around. You will see me drink something though, because my throat's going. I appreciate that. You're welcome, Megan. So yeah, if you all want to go grab a drink, you can certainly do that, or you can ask me more questions. I mean, it's open question time if you want to do that. Or you can just sit here and stare at me. I see typing going on. Local synonyms, yeah. So the way that I think about this is, so first of all, Bharat, is your machine learning model being pointed at documents written in that slang or data sources written in it, like a Twitter or some kind of social media, or are you trying to make sure that your machine learning captures that language for the search and metadata enhancement stages? Clinical notes. Yep. So when you are focusing on extraction of that slang, that's where you can turn to some of those social media, or if you have internal like Yammer or anything where people are using actual discourse where they're just like talking to each other, that's where you can mine for some of that context, if it doesn't already exist in your taxonomies. If it does, then just use those taxonomies. Here's the thing. Once you extract them, you should add them to taxonomies if you have a taxonomy internally at your company. The reason for that is you don't want to have to reprocess over and over and over and over again. You want to make it repeatable and, not just repeatable in the sense that you don't have to reprocess a lot of full text again, but more so that if you decide to leave the company and your boss needs to figure out how to redo the project you just did, there's reproducibility. Could you point to some resources of how to encode the context in ML system? How to encode? So usually when you're looking at the ontology is dictating how the instance data is structured. So are you trying to get your machine learning models to understand the structure that you want so that when you extract text, it can put it into the ontological model? Or how are you using the ontology? I think it's Xenia who's asking this. They are typing. I want to make sure I use proper pronouns because I don't see pronouns. Yeah, I think it's really interesting that there has been such a broad application of machine learning now in NLP, and it's just become so much more mainstream. And yet I hear all the time people trying to train models on all the wiki data. I have been there, done that, and learned so many hard lessons. Don't do that. Be very aware, using some of the stuff we're covering today, to be aware of what's going into your system. If you're dealing with pre-tagged training materials, this presentation will also help you understand. I think oftentimes people think that the human tagged training sets are like the best way to go. While that might be true in some senses, there are still things you need to watch for, like we've covered here. Okay, so I'm coming from NLP, so just trying to imagine how it would work. Let's say in NLP we encode words using vectors. How do I include them? It's a very specific question. I wonder if there are standard approaches. Okay, so normally you don't use, and for anybody that disagrees with me, please let me know. I don't use the ontology in my machine learning models. Usually the ontology is really to dictate the structure of the vocabulary itself. So it's levels of abstraction, right? So you've got your full text or your unstructured text, and you gather things from it, or you gather things from human people. Like a taxonomist, for instance. So you get terminology. A taxonomy is something that you can create, and we're going to do that after the break. Well, hopefully you all get to do it. If you're in Web Protege, you would use that taxonomy, and it's the standard, by the way, to create a taxonomy is ANSI Z39.19. And then there's another one if you're doing mapping or linking to vocabularies in multilingual specifically, and that's ISO 25964. And if you need me to put that in the chat, both of those, let me know. That's the structure for taxonomy. And you can use SCOS for that. It is like similar enough in SCOS XL for capturing the taxonomy in ontological-like form. But then after that, yeah, an ontology is just structuring the form of those topics. If you want to use that in your machine learning, the ontology is just going to tell you books have authors, right? It's not going to help your machine learning model that much. So you would probably want to use either the instance data where it says Mark Twain wrote, whatever Mark Twain wrote. I can't think of anything off the top of my head, which is bad. No, not Huckleberry Finn. Is that Mark Twain? Anyways, this is showing it's late in the day for me. So you could use it that way, or if you're dealing with a knowledge graph, you can do graph embeddings, which there has been quite a few presentations during Connected Data London about graph embeddings. And we will talk about that a little bit once everyone gets back and we can start back into the presentation. Okay, great, thanks. Okay, cool. Yeah, the difference between a taxonomy, a knowledge graph, and an ontology, think about it from the framework and the relationship perspective. So I already walked through how you talk about it from the framework perspective, layers of abstraction, but also relationships, right? So if you have a taxonomy, you're mostly getting broader, narrower. If you get something called a thesaurus, it's basically just a taxonomy, but with see also, use for, right? See also is a synonym, use for is a relation. So that's got a lot of context. If you can get that, you have a lot of really rich stuff to train your models on. When you get an ontology, it's really setting up for graph-like structures. So when you have a knowledge graph, you have everything that you got from a taxonomy and a thesaurus, all those same types of relations, which is broader, narrower, see also, use for. But when you get into the knowledge graph space, you start to get those implicit things like Rome is the capital city of Italy. Okay, capital city, that's a very specific kind of relationship. Something that in a taxonomy, you might just see capital cities and see Rome underneath that. And then maybe Rome has see also Italy. See what I mean? It's not that explicit, but when you get into knowledge graph, you're like, aha, it's a capital. I know that now. I know that as a human. I know that from the research, and the NLP that I'm mining with has found that in the literature or my training sets. See how those differences come together? Okay. All right, cool. Okay, so I'm going to jump back in to the presentation mode. Or the guys will help me do that. All right, sharing my screen again. Okay, so I know this was one question that came up from an audience member before, but where does this all live in the architecture? You know, so often we're talking about modeling and how do you train the machine and how do you get the export, blah, blah, blah. But where does it actually live? So this is an example architecture. This is just from the AWS website. I have a much more specific one that I go over on my YouTube channel, but there's a lot of other more specific architectures out there you can look at, but I'm an AWS shop, so that's why I'm talking about AWS here. You can see here that Textract is used to actually mine out the text, and then you're using Comprehend to actually find meaning within it. So you can use these approaches for the machine learning and the knowledge modeling in your pipeline before and after product. So before product, you're going to extract the data from your unstructured, or maybe even it is somewhat structured, for auto tagging, so auto indexing content, or enhancing it for your search. And you're also going to be able to add to it with human in the loop. That's what HITL is, human in the loop, for machine learning training. So that's where you would get some of the auto tags from your machine learning models, and then you would have your confidence scores, your F measures, and you would want to have a cutoff for what confidence you're willing to accept. And then what happens a lot is it goes out to product with those basic things, but then the human indexers, or if you have like a quality assurance or something, goes back in and can tweak it if needed. Or it happens after product, which is the extract data from the structured, because at this point you've already got structured now, for ML enhancements. So that would be like query expansion, recommendation systems, that sort of thing. Like when somebody's clicking on this article, they want this article, or when someone clicks on this product, they might be interested in this one. Or if you're in the legal or financial space, well, when somebody's looking for risk assessment models, they probably should also look at this other topic, because we just know that from our modeling. That's I think where the knowledge graph piece is really, really strong. Whereas taxonomies and more just like straight up NLP is usually something that I find helps before product. Okay. All right, so what you do if your own data is missing context? So some of this has been covered in the other presentations, so I won't go over all of them. So for instance, the KGE models, those were talked about, I think, in Tara's stuff yesterday. So all of these help with form and perhaps your vector analysis. But how does this translate to open world logic and users' cognitive models? So this is something that I really appreciate, because I started out life as a linguist. I wasn't a computational linguist at that point, but obviously I've moved into that space. One thing you have to be very aware of is your models are used by end users. They have to find value in whatever you are doing, unless you're doing business intelligence, where you have a much smaller group of people you're checking to see if your results are valuable, because they're using it then for something else. But if you're using this for search or for enhancement of content of any sort, that's really where you do need to understand how is your end user interacting. So that's where you need to start using A/B testing. That's where you need to start, if you have a user experience group, or if you can put things out as open source and see how people are reacting to it, that's really important. Some other methods just to note that I have used. So for node attributes, this is more like the characteristic similarities. Using top to vec a lot recently, and NLTK. For structured features, connections and types of connections. So these are like more specific relations. That's hierarchical, agglomerative clustering, and doc to vec. I'm using the agglomerative a little bit more right now than doc to vec, just because doc to vec seemed really, I'm going to say really slow, but it was somewhat slow. And then node embeddings, which I think a lot of you have already walked through, and that's node to vec and BERT and some of those other applications. So this will give you some of that context, and it will give you some of that structure. But you do need to be, like, if you go out and you look at any of these tools and their examples, they're very, very, very basic tree structures. It's not going to give you the context that you think it's going to. So that's where you really can benefit from having taxonomies and knowledge graphs that have a much deeper specific instance and definition structure and roll-up structure that you can infer a lot more from. Okay, so retaining or recovering context. So here's some great resources for you to use. So when you're just dealing with vocabularies and how sometimes they have issues with them. So there's WebVal. You've probably all seen visualizations from this. That's a good one to look at what kind of connections and how they relate to each other, sort of like a logic check on the models. The ontology pitfall scanner, which I always find hilarious because all the big ontologies out there always have errors. Like it's the official one, yet they still get errors. I always take heart from this that your data models, you all know, are never going to be perfect because, I mean, we're all in data science. We know it's not going to be perfect. It's always the outliers or the weird things that happen. But to know that the main people in this space also made a lot of mistakes, and yet we're all still using their stuff makes me feel not so bad about my own models. RDF triple checker. This was really helpful. It actually kind of just walks through like if your triples make sense and are structured well. If you are not using the linked open vocabulary website, definitely do that. So again, some of those questions that came up yesterday, well, what other options are there for type of and part of? Literally go into the LOV website and type that in, and you will see all the other vocabularies that have something similar or the same as that. You can see how often they're used, how they're using it. You can link out to the actual framework. It's really helpful. I mean, I use LOV maybe 2 or 3 times a week. That's how often I use it, because sometimes I go in there and I'm like, wait a minute, I just got this publisher. All of their data is music and classical, sheet music. I don't know if I have that in my model, and I don't know if I have terminology to support it. So I go and I search for, what was it? It was Maestro or something in LOV. I found a schema. I checked it through the logic that we went through here in this presentation, and I used it. Some other tips and tricks here. So sometimes you'll get very large data sets, hierarchical data sets, taxonomies, or even knowledge graphs. And you'll get really broad topics and really specific topics. And I already mentioned there's some issues with those two things. So sometimes take the middle ground, take the median. Things that are, so a good example is history. North American history, 19th century history. You see how this like hierarchy can get like kind of crazy, and you don't necessarily need that context because it's the same context as I am a human. That can be helpful, but it's something that maybe shouldn't be in the indexing or in your models per se, because maybe everybody is a human. But that's something that is an example where you wouldn't necessarily need to take that from the taxonomy. So if your taxonomy is like 27 levels deep, maybe take just the middle part. And I have found a lot of use for that, because the more specific terms you're going to get from your regular old feature extraction. So that would be probably helpful, where you don't necessarily need to train on those because there's most likely not enough context or content to train on those more specific topics. All right, so blast the combo tags. I mentioned this earlier. It means when you see terms that tags essentially that are overblown. So deep learning in health organization assessment methods. Should that be a tag? Probably not. And if you try to as a concept, maybe you'd be able to train on that if you're using knowledge graph. But if you're just using it for tagging or query expansion, that's going to be a hard one. So think about how you can parse out different components of long combo terms. This is another one. Only take the MVP. So if you are a product manager or thinking about being a product manager, or you have to think about the cost of what you're doing, everything you train your machine on costs money. The models cost money, maintaining those models, quality checking those models, putting that topic in your taxonomy as an entity to begin with costs money. And anytime you put it into your search engine, you have to make sure that it's going to pay off doing so. So there is a very slippery slope where a lot of taxonomies and knowledge graphs are built for completeness. And as much as we would like things to be complete, that doesn't mean it's going to benefit the company or whichever use case you're dealing with. So in that situation, you need to make sure that you have enough content or assets to support that. Or you know that when that is being tagged with your machine learning model, that it's going on enough content to be of value. Or it's something that you know your end users are searching a lot. Maybe you have search logs that you can look at, and you know that that's something that they are looking for, even if you don't have a lot of content on it, for instance. All of those things, my team does it. I would highly suggest doing it, is value of a concept. Have, certain data points, certain ways to check, do I want to bring this new concept into my model, my knowledge graph, what have you, and do I want to keep the ones I have? So this is something like you can build into retention and versioning. Periodically go through and check, does this thing still have value to me and my users and to my business? I can't stress that one enough. That one is so important, because anytime you find an error in your model, or anytime you have to reprocess or reindex something, the more stuff you have, the more expensive and longer it's going to take. And the harder it is to find where the real problem is. So if you have true confidence in everything that's in your model and everything that's in your taxonomy and your knowledge graph, it's not as mind-numbing to go through and find issues. Nearest neighbor or within 3 tags. So this is something that you can get around that over-indexing. So if you see all the different tags, extract the top 3 unique things, and you can look at nearest neighbor of those 3 things in your text, and that will give you better tags for your training sets than taking all the tags together, because there's going to be over-indexing in there. It also will help you grab the top 3. You want to only look at 3 to 10 tags for pieces of content. So if your content is so over tagged it has more than that, or it only has 1 tag, that's probably a category. If you have over 10 tags, it's over indexing. You see how that works out? Neither are good for machine learning. So if you can grab your vocabulary and you're only focusing on those 3 to 10 topics and their path for their hierarchy, you're going to get much better results. In a similar fashion, triangulation is also in this category, where if you don't have any metadata to understand Jupyter in your vocabulary, go and find at least 2 other vocabularies that are of similar nature, or use those other vocabularies instead of the one that you're looking at to give you that context. If you can, it doesn't always work out. And then distinguish type from part. And you can do this via k-means cluster analysis, which is one of my favorite ways to do it. You can do with straight up vector analysis, just understanding, is this thing parts of a larger thing, or is this thing similar enough but in a smaller quantity, meaning that it's more of a type of something. So definitely being very distinguished with that. And then balance natural versus preferred labels. So the thing you drive around and outside, is that your vehicle? Is that your automobile? Or is that your car? And so a lot of preferred labels are very studious, the things that you would find in a dictionary. That's not always the words. Like, I think somebody just asked about slang. those are not the words people are using, even in very structured disciplines like medical. So you do want to make sure that you have a balance if you can get it. Again, anything that is from your end user that is natural language, and when I say natural language here, this is a good point. NLP is different than natural language. Natural language, when I say that, it's according to Hobbes' discourse analysis, which I'm a big fan of his research. And that is the words that you and I use when we're talking to each other, or the words that you use on social media, or the words that you would use in like Yammer, conversations with colleagues. Those are the real words that we use. When we say NLP, we're usually talking about extraction of structured text, or even sometimes, or oftentimes unstructured text. And that's not always natural though, because the way that I would write a research paper is not how I'm talking to you right now. I am much more academic in my speech when I am writing articles. So that's the difference. That's really what I mean by that. Okay, so how to add in. This is using existing linked open data that has a lot of context. Linking your data sources. Sometimes you have data sources at your own company that could actually give you some more context. You're just not doing it. Or you are just scraping information and not actually linking to it. Again, you can't always link to it if it's not linked data, but if you can, you should try to use the linked data, the URL for something. Types versus categories. Adding those in. If you don't have a taxonomist and you want to start to structure your own tags for your machine learning because you want to take advantage of this context that we've been talking about, at the very least, do categories. That at least helps add context in a bucket-like fashion. Just don't make the mistake that I made and consider them synonyms, because they're not. I didn't know about that. I wouldn't have done that purposefully if I had known that. Confidence scores. So when you're dealing with tags that are aboutness, nothing under 75% should probably be used, unless you have a really good use case for it. And if you're dealing in things in medical and sciences that are dealing with real people's health in like live environments, I mean, anything under 90% is kind of risky. So just be very aware of that. And if you can add that confidence score into the data, that's really helpful. And I mentioned this before, but A/B testing is your friend. If there's anything you can do to make sure that it's like that logic check, the gut check, to make sure that your models could have great confidence scores, could have great F scores. But did they make sense to a real person, to the main people that are going to be using that data? It's a really important step that I think a lot of people in machine learning, including people on my team, forget. So I'm there to remind them. And then retaining the context. So if you have your own data set, how do you retain the context? Please make sure you have UIDs. That's pretty important. If you have URLs, meaning it's registered, it can be resolved. It's even better. Not everybody can make their data external like that, though, and that's understood. But sometimes you can have URL that doesn't resolve to anything, which means it can be used as linked data internally in your own systems, but it doesn't have to be linked data for external users. Please use provenance. I think we've covered this ad nauseum already, but it's incredibly important to keep adding this to your data. Test. Because as you probably all know with machine learning models, they can become out of date. They can go awry. The content that you are using your machine learning models on, whether it's for analytics or search engines or auto tagging, you really need to test it to make sure, not just once, but constantly, that your model hasn't gone off kilter, or that it's still relevant if terminology is changing. And here's the thing that we will end the session on, which is train your indexers, your digital asset managers, your knowledge managers, and your ML engineers on these practices. So if this is something that you can take away and talk to your people on your team that do this, that would be incredibly helpful, because at the very least, this teaches you not how to make a taxonomy, although I'm going to show you a little bit about that in a second. This is showing you how the taxonomists are thinking, so that, and what is very common in those vocabularies and other linked data sources, so that you can watch out for them and try to combat them when you are trying to use it in your own modeling. But training your folks on this is a good step for responsible AI. Just making people aware of these things, because obviously a lot of librarians that make a lot of these data sources, they're not trying to do harm. They don't realize they're doing so much harm, but educating them on it is a good step. Okay, so just when you're looking at the difference between mapping and linking, that's what you're seeing here. So a crosswalk is mapping and a hub structure is linking. So crosswalk is very common in information science, where you are mapping one concept to another concept over and over and over and over again. So you're saying this thing is the same as this thing over and over again. It's synonym mapping across different data sources or different synonyms. You can see, though, it's not that effective once you get past a certain level of vocabularies. That's where the knowledge graph and other mapping structures come into play, linked data structures, where you have your central node, your UID, and then you're mapping as contributing vocabularies, all the other data sources that you have. And that's the hub model. And it's much more efficient, and you can see why. So if you are using data sources that are mapped, check to see which one they're using, because this helps you understand how hard it's going to be to update or maintain a data source that you're using from external or even internal data sources. Because if they're using a crosswalk, I hope you have a few months to wait for an update, because that's how long it's going to take. Whereas with a hub structure, it's way more automated. Some good tools that allow you to do this is, again, Pool Party, OntoText, usually things like Tiger Graph, and those are just pure data, graph data. It's not really like the other, linked data pieces. It's usually RDF triple stores that do that. But it's incredibly useful if you can get that, because that helps you give a tool to subject matter experts to keep adding and feeding in context to your machine learning models. That's really helpful. Okay, so I am not going to walk through how to do this. And we've only got about 15 more minutes. So what I am going to ask you to do is, and I'm going to stop sharing and go back, hopefully, to, there we go, to the chat. So here is when you can ask me questions. But if you want to actually walk through how to do the protege, the web protege work, right now, if you could put your username in the chat if you don't have access to these projects, that would be helpful. And you don't have to do this on the fly with me. Okay, I got one. So yeah, you don't have to do this with me, but you're going to get these the slide deck after the presentation. So if you want to go in and try your hand at actually putting this structure into place, this is the way to do it. Okay, let me go and make sure that I've got everybody in. Is it allowing me to do this? Let's see. Bear with me while I get everybody's in. There we go. Okay. Now for this next portion, don't think for a second I'm thinking that you're all going to be taxonomists after this. This is going to be something that we're going to walk through so you know how the taxonomists do their work and how they add hierarchy. And we're going to walk through it together so that if you did have to do a quick and dirty taxonomy, like adding context to your flat list of extracted terms, you have the ability to do that. So that's what we're going to do here. Okay, so. Okay. So the first project I am showing you, if you go into Web Protege now, you'll see it, most of you, is called the EDA project. And this is, if you do anything in medical, this is a really great one. And I don't just say that because I helped make it. I was actually, this is something I created before I was done with my PhD program. And so I was not the lead creator on this. I was actually working with the University of Pittsburgh Medical Center on this. And I was the knowledge engineer that was doing a lot of the data entry. So, okay, let's see. Do I have everybody yet? Okay. So this vocabulary, if you don't want to use it in the Web Protege, this is also available on BioPortal if you just type in EDDA. So that's the one we're going to be using here. All right, I think I got everybody. If not, I will add you after to this. So let me take a real quick screenshot so I can make sure that I can get everybody. So this is me taking a screenshot. Okay, cool. All right, so I think I got everybody in. If you don't have access, just bear with me. Because I can add you after the fact. I am in things. Okay, cool. All right, thanks, Mark. Okay, and so in the last remaining amount of time, I am going to share my screen again. Can I have the ball back? You can tell I used to use WebEx. Can I have the ball? Like nobody says that anymore. Everybody's using Zoom. All right. So what we're going to do, and I have screenshots in here, so when I share this doc with you, you can do it yourself. So we're going to, and we're not going to do all of these. We're going to do one of each. So add 3 external data sources. So external, right? We want to use something that has a URL so that we can do that real linking of the project. Then we're going to add 3 internal from a machine learning project that we have, which is another vocabulary. Then we're going to add some metadata. So let's do that. So here's the machine learning. So here's the use case. You have a new department or you have a new project where new terminology needs to be added so that people can find this information, or the new department can add these tags to their assets that you're adding to whatever you're doing. You as the machine learning people need to make sure that this information is expanded in search or is automatically tagged or is used correctly in your analytics programs and models. So that's how you would interpret this. So you would see some of these things. So let's take adaptive systems, and it has a URI. So I'm going to grab that. Now we're going to go over to our target vocabulary. So the source is the source that you're mapping in. Target is what you're mapping it to. So this is a linked data piece, and we have adaptive design, which is great. So we don't see anything in here for adaptive systems. So we're going to go ahead and add that. So we would click it here. Now, here's something to think about. See these things called variant? Well, that doesn't look like a good SCOS property. You'd be right. These should be used for, right? Like that's a synonym. Or alt label is technically what it would be in SCOS. So when I grabbed this vocabulary, I had to look at how the original vocabulary was created so that I could then put it into a real schema to SCOS framework to be able to use in my machine learning models, because I've already trained my machine learning models to use SCOS. So now I need to get this into SCOS. So the way to do that is I see this thing called variant. I'm going to go to the properties. You can see variant, and you see here that I have this now updated to the IRI of alt label. So that's how I did it. I created this as basically a different label for alt label, but now it is truly connected to SCOS alt label. So now it's going to make sense for my machine, because as a human, I can read this in this way, but if I wanted to change the view, I could do that to only see it as the URI if I wanted to. All right, so adaptive design, and what are we adding in? We're adding in adaptive systems. Okay, so I'm gonna do adaptive systems. Now, the nice thing is this is going to be the class name. So I'm just doing that so I can read it. Typically, you wouldn't even need to do that because the URI should be able to link out and grab that data, but you don't want to always do that on the fly. I'm going to drag it. Oh, actually, I don't need to drag it. Let me show you how to do this, because you could drag it if it wasn't such a big vocabulary. So you can see the parent is study design. I don't want that to be the parent. I wanted it to be adaptive design. So adaptive. I start to type ahead. That's why Web Protege is way easier than Desktop Protege. If you've ever tried to use Desktop Protege, it definitely has more advanced features than Web Protege. But if you're just starting, Web Protege is the better one. Okay, so we want to say adaptive design, and we want to get rid of study design. And you'll see it's now where it belongs. Now, what I want to do is I want to put in, do we want to put in classification? You can see here that it has DC source, so you can see where the source is coming from. You can see what the label is. If I wanted to add this in, I would go ahead and do it the same way that we just did. But let's go back and do some metadata, right? So if you wanted to add in some definitions, you type in SCOS, it gives you a drop-down of all the different SCOS labels, and we're going to say definition. And let's say adaptive systems. Let's go to NCTI. No, it's NC. Actually, let me go to BioPortal. I think I typed in there. There we go. Oops. So what this is going to do is it's going to show me all the different resources that I could link in. This is the one I was looking for earlier, on adaptive systems. So you can see that PLOS has one. So let's go check that out and see if they have any definition. And it doesn't look like they do. All right. But this is a good one that we could link into. So this is true link data. This is not true link data because this is just another project that I have. So you notice that I did copy the IRI, but I didn't really use it. That's because this is an internal. It's just two vocabularies talking together at your institution. You don't necessarily need to do that. But if I wanted to use this, that's the ID. I think that's the one I would use for them. So I'm going to grab that. And I'm going to say, oh, I was starting on a definition. Now remember, I could use variant, and it means alt label. But because we all know what SCOS is, I'm going to use SCOS alt label. Oops. And I put that. So this means that if I was starting to use this information for my machine learning models, I would need to grab any of the information from an API if they had it for this. So that's something you'd want to check. If they don't have a REST API that you can call for that information, unfortunately, you will have to grab it and put it into your own vocabulary. So I know we are now out of time. So this is just to walk you through how you would use Protege. The vocabulary is here for you to play with, both of these. And if you don't have access to both, I'm going to have it for you by the end of the day, where you can take some of this, map it in here. You can go to BioPortal, search for things, map it in here. As machine learning experts or people that are trying to understand how to add back context to your vocabularies, this is a great way to do it, but you need to also understand how to roll things up and classify them. So I showed you how to add some of that information, but what if I had a new area, right? All of these are machine learning things. I used adaptive systems because it already existed, but the rest of these are machine learning. Well, let's see, machine learning. Oops. Do I have anything about machine learning? No, nothing. So what that means is I can add something, right? I'm going to add a category. See, a lot of these already have categories. And in the slide deck, I have it, but I added computer science. So that's the category, and all of those terms that I'm adding are going to I'm going to put it under computer science, so that neural network might exist somewhere in the brain functions and the health side of my taxonomy, but it also might show up in my computer science. But because of the path, the roll-up of the hierarchy, and some of those knowledge connections that you can make also in here with relationships, meaning capital city of, adverse effect of, you know, those knowledge graph kind of semantic relations for a triple. If I can start to add that into my machine learning models, I'm going to have much more context. It's going to be much more reliable. And I can also make sure that I'm using something that is responsible and not introducing a lot of potential bias. I say potential biases because everything is somewhat biased, and conflicts that could hurt people. Okay, so we are now at time. And it looks like a lot of folks are having to jump off, which I totally understand. It's kind of late for many. So I was really hoping we could do more interactive things, but I completely forgot this was not something like Zoom where we could all discuss and do it together, because my plan was to make sure that you understood how to do this and then do it in practice. You can still do that. You're just going to have to wait until you get my deck. But you do have access to the projects if you want to go and test it out. All right, so with that, is there anything else that folks want to talk about? Was there anything that was confusing? Does it make sense as to why taxonomies and knowledge graphs help add that context back into machine learning? And do you see this as a problem today? So I see a bunch of thank yous. Thank you. Thank you for sticking with me this late into the day, because I know it's probably rough after a previous masterclass. All right, cool. So it looks like everyone's got to run. That's totally fine. You do all have my email, and if you don't, it's afaith@ebsco.com. And you can also find me on LinkedIn and YouTube if you want to learn more about this and connect with me after. All right.
And just, yeah, short thank you from me. I've really enjoyed that session, actually, and made a whole ton of notes. So it's been, yeah, incredibly useful. And I think from the comments, everyone else has found it really useful. So, so thanks for preparing such awesome content.
Well, thank you. And, apologies if some of it was, yes, of course, I know. I never know like what the happy balance is with groups, but just speaking from my own experience in machine learning land, these are, if I could teach my past self some of these things, I would have had so much more success with early projects. So hopefully I've imparted that to some other folks that are trying or struggling with this as well. All right. So I guess that's a wrap.
Cool. I think so.
Cool.
Great. Well, yeah,
Okay.
thanks everyone, and thanks Ashleigh. Have a good afternoon, good evening.
Thanks, and thanks for everybody that stuck around. And thank you, James, for being such a great moderator. I'm glad I didn't have to figure out all the back and forth stuff.
No problem. At least I could do it. Saw myself as more of a participant, to be honest. But yeah, it's been great fun.
Great. All right. Okay. Well, have a great weekend, everybody.
Right.
See you later. Bye.
Bye.